Hi friends, welcome to another video on analog electronic circuits. So in this video we'll see the design of common emitter amplifier, which is popularly known as CE amplifier. So let us write the circuit diagram, do some assumptions, and then start doing the design. So now let me write the circuit diagram. So the coupling capacitor. This is where I take the output. This is V, ground, R1, R2, RC. This is capacitor, sorry, transistor Q1. Let us name some currents I1, I2, I3, whatever that is. So let this current be collector current. Let this current be base current. Let us assume a current of I1 flowing through this R1, R2. And this is coupling capacitor. This is VCC ground. If you write the Okay, let us make some assumptions. The beta of this transistor, let it be 100. The IS, that is the reverse saturation current, let it be 1 into 10 power minus 13 amperes. And we'll assume that thermal voltage is around 26 millivolts. So these are certain assumptions what we are making. And let us start writing the equations. Equations that what we have is, so IC is equal to IS exponential VBE by VT is one expression. The other expression what we have is from the circuit, and of course we have the other expression as beta is equal to IC by IB. This is for the device. This is for the device, the transistor. These are the expressions, and for the circuit, this is for the device. For the circuit, expressions are if you write the KVL for this outer loop, VCC is equal to IC into RC plus VCE. So this what is VCE, what we are talking about. And on this side you can write VCC is equal to I into R1 plus R2, this entire thing, and you can write the voltage at this VBE is equal to if you this is what we named it as I1, it is nothing but can I write it as VB is nothing but R2 into VCC by R1 plus R2. So this is what is the voltage between this and this. VB is VCC into R2 by R1 plus R2. And so these are all some circuit equations. These are device equations. With these things, of course, we have the CE amplifier expressions as GM is equal to IC by VT. This is for the CE amplifier. And we have the gain AB is equal to minus GM into RC. And what else we have? Okay, we have these other expressions, which is nothing but V naught by V. So for this circuit diagram, these assumptions, this is for the device equation where collector current is given by so and so, and we have the amplification factor beta is equal to IC by IB. And for this circuit, we can write these expressions. And for the CE amplifier, we can write this so and so, and we can write the small signal model for this as something like this. This is R1 parallel R2, and then you'll have R pi for this transistor. This is R1 parallel R2. This is base, and this is collector, and you have this as gm into v pi. Usually this is called as v pi, and you have this as rc. This is your, so this is the small signal model. This is v. Okay, with these equations and assumptions so on, so let us start a design. So for starting the design, so let us have uh, a IC of 1 milliampere. Let us assume uh, the value of beta as 100. Of course, let IS be 1 into 10 power minus 13 ampere. Let VT be 26 millivolt. Let us have the DC voltage of your that is, let your output voltage swing around 2.5. Let us have V capital C as 2.5 volt to get maximum swing, and let us find the gain, and of course find the values of R1, R2 and RC along with all these things. Okay, let us start the design. We are asked to find R1, R2, RC so that all these things are met. So this is my circuit diagram. Since we know that okay, this VC nothing but VCE, so can I write, I can use this equation, but of course we are assuming VCC to be 5 volt. So from equation VCC is equal to IC RC plus VCE. So this is 5 is equal to 1 milliampere is equal to RC plus 2.5. Therefore RC is equal to 2.5 kilo ohm. 2.5 kilo ohm. So you don't have a 2.5 kilo ohm. So choose RC of 2.2 kilo ohm. Since it is 2.2 kilo ohm, so what will happen? Then VC will be 5 minus 1 milli into 2.2. Then this will become 2.8 volt, which is not a bad idea. So instead of having a 2.5, you'll have it at 2.8. So you'll have it at 2.8, which is not totally bad idea. This is 2. Okay, fine. So this is done with the value of RC. So we are done with the value of RC. Next, we need to find what is R1, R2. So to find R1, R2, so now we have been given that IC is equal to 1 milliampere. And of course, here we have to assume one more thing. So we have this I1 and IB, no? So let I1 be 10 times IB. This is another assumption for the circuit. This IB what you have, let it be hardly 10% of this, or this I1 is 10 times the IB. So this is a large current compared to this by 10 times. So that's what is I1 is 10 times IB. This is another equation you have to that's what is one of the assumption. Why means, because if you are getting some current, so let me have 10 times of that current here, so that this is not feeling the loss of this small current that is going into the base of the capacitor. So now what I have, IC is equal to, because now the RC is found out here. RC is found out here. Now there is the question of R1 and R2 I need to find. So to find R1, R2, IC is given as 1 milliampere. So using beta of 100, what is IB is equal to IC by beta, which is nothing but 1 milliampere divided by 100, which will be, how much is that? 1 exponential minus 3 divided by 100 is actually 10 microampere. This is IB. So you have I1 is equal to 10 times IB. I1 is equal to 10 times IB. Then this is equal to 100 microampere. What is I1? I1 is equal to 100 microampere. So you have this equation. So I1 VCC and R1 R2 we know. So how much is this? From this equation, I1 is equal to VCC by R1 plus R2. You know I1, you know VCC, then what is R1 plus R2? Therefore, R1 plus R2 is equal to 5 by 100 micro, which is nothing but 50 kilo ohm. So, R1 plus R2 is equal to 50 kilo ohm. So, we still don't know what is R1, what is R2, but their summation is 50 kilo ohm. And we have another expression for IC. IC is equal to what? IS exponential VBE by Vt, from which we can write VBE is equal to Vt ln of IC by IS. This is how you can write from this. So what is VBE now? VBE is equal to 26 millivolt into ln of 1 milli by 1 into 10 power minus 13. So how much is that? Just carefully see this. So we are done with R1 plus R2. Let me again redo it. We have another expression. IC is equal to IS exponential VBE by VT. This is which can be rewritten as VBE is equal to VT into ln of IC by IS. So from which 26 milli into ln of 1 milli by 1 into 10 power minus 13 ampere. So this is how much? It is now ln of 1 exponential minus 3 divided by 1 exponential minus 13 into 26 minus 3. It is now 598 milliwatt is my VP. So we have another expression for VBE. What is VBE expression? VBE is VCC R2 by R1 plus R2. So from this, what is VCC? It is 598 millivolt. This is equal to 5 into R2. What is R1 plus R2? It is 50k. So find R2. So what is R2 now? It is 598 exponential minus 3 alpha equals, upon the parenthesis, 5 into alpha A divided by 50 exponential 3 shift cal. I need to remove one of the. Okay, now R2 comes out to be 5.98 kilo ohm. So R2 is now 5.98 kilo ohm. So what we have is RC is equal to 2.2k. R1 is equal to, R2 is equal to 5.98 kilo ohm. R1 plus R2 is equal to 50k. Therefore, R1 is equal to how much? How much will be R1? It is 50 minus 5.98. It is 44.02 kilo ohm. These are the values what you got using the equation. You can see this is 2.2 kilo ohms also, but practical, of course, you actually got it as 2.5k. 2.5k. So now we will use a circuit diagram such that we will use, this is 5 volt. Let this be a 0.1 microfarad. Let us use it as 2.2 kilo ohm. This is my RC. Instead of 2.5, let us use 2.2 kilo ohm. Instead of 44 point something, let us use 47 kilo ohm as my R1 value because it's a standard value. Instead of having 5.98 kilo ohm here, let us use the DRB. Let us use the DRB. Let us keep that around 5k to 6k. 5k to 6k. So now if you use a DRB, it's possible to change the value so that the voltage here becomes 2.5 volts. You have to keep this at 47k and vary this so that this voltage will become 2.1. This voltage will become 2.1. So it is very essential that you have to write the circuit diagram, the device assumptions. This is device assumptions. This is device assumptions. These are device equation. So for the device we have some equation, and this is the equation for the circuit diagram, and this is for the amplifier. This is for the amplifier. So now, so with the specification that IC is equal to 1 milliampere, beta is equal to 100, IS is equal to 110 per minus 13, so on. So let us design a circuit with a maximum output swing. So let this be 2.5. So now you have to find what is, of course, let us not, we are not yet found out AV. So we actually found the values of the resistors RC, R1, R2. RC can be found very easily using that equation of your output loop, which is VCC is equal to ICRC plus VCE. So RC comes out to be 2.5K. So use 2.2 kilo ohm. Of course, this will slightly change. If you change the value of IC, then this comes out to be 2.5 volts. So now this what is the equation to find R1 and R2. So you know the expression for, of course, we know the values of IC and beta. We know the expression for base current, which is IC by beta, which is 10 microampere. We also know the relation between I1 and IB, which is 10 times of IB is I1, which you get this, and I1 is related to R1, R2 and RC, sorry, VCC by this. So R1 plus R2 comes out to be 50 kilo ohm, and then we have another expression for VBE, which is in this form. So when you equate both the equations and then you try to get the other value of R2 and then R1 also you can find out. So you can use these values. So how do we find the gain? AB is nothing but minus GM into RC. We know that GM is nothing but, of course, let me just take the my IC by VT multiplied by RC. So how much is IC? It is 1 by 26 into 2.2 exponential 3. So you are looking for a gain of minus 84.6 is the gain. So it's expecting a gain of around 84 volts. 84 volt per volt. This is 84 volt per volt. This is how you should do the design of C amplifier. Design is a must. You have to write the assumptions, device equation, circuit equation, and amplifier equation. Then proceed with the design. And similarly for CC amplifier, it's on the same lines. So for CC amplifier, this is the circuit diagram. This is VCC, R1, R2, RE, serial measure V0. This is V in CC. Again, as we assumed for C amplifier, for the device you have beta is equal to 100, IC is equal to IS exponential VBE by VT, and then what you have, the parameter what you have is, this is for, so you're going to have thermal voltage VT is equal to 26 volts, and of course IS is nothing but, so this is your equation. IS is equal to 1 into 10 power minus 13 ampere. The expression for beta is IC by IB, and for the circuit what you have is Suppose if you consider this is current I1. So what is I1 is equal to VCC by R1 plus R2. If you consider this as voltage at base, VB is nothing but VCC R2 by R1 plus R2, and that is also equal to VBE plus, suppose you get this is the current IE, which is equal to IC. You can say it as IC into I. IC into I. This is VB. Whatever voltage VB you have, which is nothing but this also, and this. And you have this is your IB. I1 is equal to 10 times of IB. That is still as it is. This I1. This I1 is equal to 10 times of I. So these are all the, and of course you have the expression for AB is nothing but GM RE by 1 plus GM RE plus GM RE by GM RE by 1 plus GM RE. Of course you have the expression for GM as IC by VT. IC by VT. Now if you do it for IC is equal to 1 milliampere, and to have a maximum swing, so let us have VE is equal to 2.5 volt, 2.5 volts, and then what you have, so let us assume beta of 100, so let us assume IS of 1 into 10 power minus 13 ampere. With these specifications, if you are asked to design, so you start with VE is nothing but IE into RE, which is nothing but IC into RE. You want to have this at 2.5 volt. So then 2.5 volt is equal to IC is 1 milliampere into RE. So RE comes out to be 2.5 kilo ohm. So this is the value of RE, and we need to find now R1, R2. So what is IB? So IB is given by IC by beta, which is nothing but 1 milliampere divided by 100, which is 10 microampere. So I1 is nothing but 10 times of IB, which is 100 microampere. We also know that I1 is equal to VCC by R1 plus R2. So from which you can know R1 plus R2 becomes VCC by I1, which is 50 kilo. So we know R1 plus R2 is 50 kilo. This is 50 kilo. Then what else you have? You have another expression. VB is nothing but R2. It is VCC R2 by R1 plus R2. That's equal to. So that should be equal to what? VB plus V, which is nothing but, how much is VB now? VB is equal to VT ln of IC by IS, which is nothing but 598 millivolt. V is equal to 2.5 volt. Therefore, VB is equal to suppose if you assume it to be 0.6, so then this will become 3.1 volt. So VB is equal to 3.1 is equal to VCC R2 by R1 plus R2. So from this, you know what is R1 plus R2, you can find what is R2. So it is 3.1 is equal to 5 into R2 by 50. Therefore, R2 is equal to, how much is R2? It is 3.1 alpha equals 5 into alpha A divided by 50 exponential 3. Is it not 31 kilo ohm? So R2 required is 31 kilo ohm. R2 required is 31 kilo ohm. Then how much is R1? R1 is equal to 50 minus 31, which will be 19. So minus 50 function 3, it is 19 kilo. So RE is 2.5k, R1 is 19k, R2 is 31 kilo. These are the values that you obtained using the equation, but while using it in the circuit diagram, so these are the values. So it is 2.5k, 2.5k, and what you can do is you can use 2.2k here, you can use 33k here, sorry, you can use 22k here, you can use a DR. So the best we end up with R1 is 19k, R2 is 31k, and RE is 2.5k. So how do you choose the values? Because you have to choose the standard values. Use 2.2 kilo ohm as your RE. Use 22 kilo ohm as your R1. Use a DRB around 30 kilo ohm. So you have to keep varying that. Keep varying so that this voltage will become 2.5 volts. This is R2. Correct? This is 22k, around 30k, 29, 30, 31 will change, and so that this will become 2.5 volts. Apply input voltage so that you get a comfortable output voltage. So with this, maybe you can just roll back, see the equations, write the equations once or twice. You'll be comfortably getting all this. Thank you.